The world around us are made up of matter and tiny particles, including our atmosphere. And an atmosphere has a mixture of gases, which includes the nitrogen and oxygen, with 78% of nitrogen and 21% of oxygen. Thus, this mixture of gases is what creates atmospheric pressure because it exerted force on surfaces. This topic will explore and discover more about pressure and how to measure atmospheric pressure or the pressure of gas using these two scientific instruments, which are the barometer and manometer. So these three are the overall focus of this topic, which include the pressure, atmospheric pressure, barometer, and manometer. We are used to living at 1 atm pressure, but we hardly notice it because the human body is made up of liquid, and liquid is considered as non-compressible, meaning it can be compressed. But externally, we do notice changes of pressure in our ear. We sometimes notice it popping, especially when we drove onto the mountain, because our ear has an air spaces in them, and we considered air or other gases as compressible. Why does pressure decrease with higher altitude? So the greater the altitude, the fewer air molecules or oxygen we get to our body. It happens when the force of gravity or gravitational pull weakens. But when the altitude decreases, air molecules or oxygen increases, which means that when we are closer or we are nearer in the Earth's surface, the force of gravity or gravitational pull are much more stronger. Atmospheric pressure in daily life can include aviation and mountaineering. In aviation, pressurization are used in aircraft, allowing the passenger to breathe normally and also to avoid the risk of hypoxia. Because at higher altitude, the air is much more thinner in color, which we need to pressurize in order to make the passenger more comfortable and to supply enough oxygen. While in mountaineering, climbers experience lower pressure or lower oxygen levels at higher altitude. That is due to the decreased atmospheric pressure, and when it decreases, the partial oxygen also decreases, which means that it is very risky for them, especially when they stayed overnight in that particular area. So let's now proceed in knowing what is a barometer. So a barometer is a scientific instrument used to measure atmospheric pressure, also known as a barometric pressure. So using this device, it allows us to identify weather patterns, and also it helps us to determine whether the air pressure is increasing, decreasing, or it remains stable, which this device are both useful in meteorology and maritime navigation. So mercury barometer is also known as the Torricellian barometer, which was invented by Italian physicist and mathematician, which is Evangelista Torricelli in 1643. He measures atmospheric pressure using a mercury barometer, which states that if the atmospheric pressure is high, the mercury column rises, which indicates good weather. Meanwhile, if the atmospheric pressure is low, the mercury column descends, which indicates weather changes like upcoming storm. At a Torricellian barometer, the atmosphere exerts pressure on the liquid, wherein the atmospheric pressure pushes down on mercury, allowing the mercury to move forward and to keep the liquid at a certain height, which is 760 millimeter mercury. If converted into meters, it will turn into 0.76 meters, which is also equivalent to 1 atm of pressure, which this allows us to measure atmospheric pressure between atmospheres and millimeters as unit of pressure. The pressure exerted by a fluid or gravity is called a hydrostatic pressure. In solving a barometer equation, we use this formula, which is P equals HPG, which P represents the hydrostatic pressure, equals H, which represents the height of the fluid, and italic P, which represents the density of the fluid, and lastly is G, which represents the acceleration due to gravity. So this allows us to measure the pressure of an atmosphere. So let's say, for example, this equation where the height of the fluid, the density of the fluid, and the acceleration due to gravity are given, which the height has 760 millimeters mercury, or if converted to meters, it will turn to 0.760 meters. While the density of the fluid, or the density of the mercury, has 13,600 kilogram per cubic meter, while the gravity, or the acceleration due to gravity, has 9.81 meters squared. So in order to find the hydrostatic pressure, we just need to multiply these three, which is the height of the fluid, the density of the fluid, and the acceleration due to gravity, using the barometer equation. So 0.760 meters times 13,600 kilogram per cubic meter times the gravity, which is the 9.81 meters squared, are equal to 101,000 Newton squared meter or Pascal, are also equivalent to 1 atm, which this total amount represents the hydrostatic pressure. Since we already know what is a barometer and how to calculate using a barometer equation, so let's now proceed in knowing what is a manometer. So a manometer is a measuring instrument that measures the pressure of fluid or gas in a confined space. So a manometer, it is a device similar to a barometer, and it is used to measure not atmospheric pressure but rather the pressure exerted by a gas that is trapped by a container. So there is an example of a manometer, which is called an open-ended manometer, wherein the top of the tube is open to the atmosphere. In solving an open-ended manometer, we are using this formula, wherein P gas is equivalent to the pressure of gas, P atm per pressure of atmosphere, all together with the formula given of the barometer equation, which is H, which stands for the height of the fluid, italic P for density of the fluid, and acceleration due to gravity, which represents the symbol J. So let's say, for example, a given equation of an open-ended manometer. So in this equation, the density of the fluid and the height of the fluid are given, which the P gas, or the pressure of gas, are unknown, which means that we need to find the pressure of gas. So in order to solve it, we just need to use the formula of an open-ended manometer, which is the pressure of gas equals the pressure of atmospheres, all together with the formula of the barometer, which is the density of the fluid, the acceleration due to gravity, and the height of the fluid. So the pressure of the atmosphere has 101.235 kilopascal, plus the density of the fluid, or the density of the mercury, which has 13,600 kilogram per cubic meter, times acceleration due to gravity, which has 9.81 meters squared, times the given height, or the height of the fluid, which is 60 millimeters, or if converted into meters, it will turn it into 0.6 meters. So to combine this all together, we will have an answer of 181,293 Pascal. And if we want to convert it into kilopascal, we just need to simply divide it with 1000 in order to get the kilopascal. So the second type of manometer is called the closed-end manometer. So it refers to the difference in height of the two arms of liquid and are equal to the pressure of gas. So in this example, the difference in height shows 26.4 centimeters, which we can use this value to express the pressure of gas exerted in the mercury. If we want to use torr, we simply convert 26.4 centimeters into millimeters of mercury to have an equal amount of gas. A manometer and barometer can be used in various ways, including measuring weather changes and measuring gas of confined spaces. A barometer can be used in weather forecasts and altitude measurement, whether the atmospheric pressure increases or decreases on that particular altitude. Meanwhile, a manometer can be used in fluid pressure measurement and gas pressure monitoring. So this provides a simple visual presentation of how pressure affects the fluid behavior.
So this is my personal insight of my topic, which is all about measuring pressure using a barometer and manometer. So manometer and barometer are worldwide scientific instrument that plays a crucial role in our life, wherein it helps us to understand, to know, to be informed, and to be aware on what is happening around us. Thus, by proposing this, it ensures everyone's safety to avoid calamity and to lessen its impacts. Therefore, barometer tells us when the weather changes or the level of atmospheric pressure between altitude and how strong or how weak an atmosphere is. However, a manometer helps us support monitor and control pressure system to prevent damage nor accident, which is explosion.